This is 2.3, standard form of a quadratic and regression. In this section, we're going to be looking at a form of a quadratic that is very different from vertex form and intercept form. This is called standard form. In standard form, we actually don't have any parentheses. We just have terms, which means we have things that are separated by addition and subtraction. So in standard form, we have a number, x squared, plus a number times x plus another number. So A, B, and C are three different numbers. We could say blank x squared plus blank x plus blank. And so I can go ahead and label these as yellow, green, and blue, the way we've been doing. Standard form is a little trickier than the other two forms because it doesn't give us x-intercepts immediately, and it doesn't give us vertex immediately. But what it is useful for is something called regression. So what we're going to have here is we're going to have a set of points, and these points don't make a perfect parabola, but they make something that's pretty close to a parabola. So let's take a look at these dots first and see what they do. So I'm going to plot in Desmos. And in Desmos, in order to get a table created, I'm going to click on the plus sign, which I like to tell people looks like the letter T, and T stands for table. And I'm going to click on table. And I'm going to go ahead and put in the points that were given to me in here. So let's see, 2.3, 3.9. So 2.3 and then 3.9. And then we've got 5.2 and 6.4. So all I'm doing is just typing the numbers in and using my arrow keys to move back and forth in the table. And then I've got 4, 5, 4, 5, 4.2, and 1.8. Let me double check those. So you can see over here on the graph, these don't make a perfect parabola, but we can tell by the way they move that it looks like a parabola shape. And so we're going to come up with an equation of a parabola that's as close to that as we can possibly get. So in order to do that, we're going to do something called quadratic regression. So quadratic regression is really fancy in Desmos, but Desmos will do most of the work for you. So what I'm going to do is I'm going to type in a formula that you're going to use every time for regression. I'm going to type in y1, and notice when I type in the 1, it makes the 1 little. And the reason that I'm using y1 is because I wanted to use the same y1 that was in the table. So the table had a y1. The table also has an x1. We're approximating what's going on here, so I'm going to put a squiggly instead of an equal sign, because that means approximately. And then I'm going to type in this standard form. So I'm going to type in a x1, because I want to use the x1s in the table, squared, plus b x1 plus c. And you can see as we start to do that, it was kind of forming the parabola. And this is a pretty good parabola. It's not perfect, but it's pretty good. Like you can see this gray dot at the top here almost lines up with the green dot that was at the top. So it's pretty close. And I can tell that it's pretty close because this r squared value in statistics tells me how good my approximation is. If it's close to 1, it's very good. So then what we have here is we have the A, the B, and the C value. Okay, so those were listed at the bottom. So what I'm going to do is I'm going to put those into an equation. And I'm going to go ahead and say y equals, and then I'm going to take the A, I'm going to say negative 0.503. And 3 decimal places is okay. And then I'll say x squared. And I'm going to say plus the B value. So 3.865 is close enough with the x. And then minus 2.325. And we can see that that red curve matches that black curve that we had gotten. So I can hide the red curve, but that's what the equation looks like. So I'm going to go ahead and write that in my notes. And I'm going to hop back and forth a little bit so that I get the numbers right. So I'm going to say y equals negative 0.503 x squared. Then I'm going to say plus 3.865. So 3.865x. And then we're going to do minus, and that minus was 2.325. 0.325. So that's my function. That's the function that gets me closest to those points, and it fits that standard form. This parabola has an axis of symmetry and a minimum, just like all of the other parabolas that we've dealt with. So I want to find that axis of symmetry. The axis of symmetry is always x equals. So I'm going to go back to this parabola, and I'm going to go find the vertex, because the vertex is where the axis of symmetry runs through. And I'm going to tap on that point, and I want this guy. Whoops. So I want that gray point, and all I did was tap on the all of that statistic stuff to get that gray point. And it looks like 3.84. So I'm going to go back over here and say x equals 3.84 is the axis of symmetry. The minimum is the y value of the vertex. So I'm going to go back over here. I'm going to look at the exact same point where I got the 3.84, and I'm going to look at the y value, and I get 5.097. So 5.097. Okay, so the axis of symmetry and the minimum is like the vertex. So if I had to kind of summarize this, vertex is axis of symmetry. Whoops. Comma. Whoops. Sorry about that. Let's try again. Max slash min. Okay, so your vertex is axis of symmetry, and then maximum slash minimum. Let me get rid of some of this extra stuff that drew. Make it look a little neater. That's a little better. Okay, so that kind of summarizes what's going on. So let's do the same thing, but let's do it with the next one. So all I'm going to do once I have one table in there, I'm going to go ahead and just replace the values in the table. So I could go back in here, and as a matter of fact, let me go ahead and do that for this one. And I can X all of this stuff out. And I'm going to add a new table. So I'm going to hit the plus sign. I'm going to hit table. I want to make sure when you do this that it's ones, X1 and Y1. And then I'm going to go ahead and add this table. So I've got negative 5.1, negative 3.5. And then I've got negative 2, negative 0.2. And then we've got 1.3. And then our y values, we've got negative 3.3. And we've got 1.4 and 1. So negative 1.4 and negative 1. Negative 1.5. And negative 3. Okay, so our parabola is down here this time. And we can kind of see it. It looks like a pretty decent parabola. Okay, it's not perfect, but it's pretty good. So I'm going to go ahead down here and I'm going to type in this formula. So I'm going to say y1. Don't use y, use y1 because we're referring back to the y1 in the table. So the y's in the table are labeled y1. Then we're going to say approximately, and that little squiggly thing is below the escape key on the upper left of your keyboard. Then I'm going to say ax1 squared. And again, you don't have to do anything to make that 1 small. It automatically does it if you type it after the letter. So when I say plus bx1, I'm not typing anything special to get the 1. I'm just doing x and then a 1. And then plus c. So there we go. We've got our a value, our b value, and our c value. So I'm going to go back to my notes. And I'm going to go ahead. It's doing all kinds of crazy stuff today. And I'm going to say y equals, and I'm going to head back over. And I'm going to get all sorts of stuff popping up. Negative 0.217. So negative 0.217 x squared. Then we're going to get an extra window and negative 0.789. I'll just keep opening up stuff all over the place. 0.789x. And then negative 1.629. So that's our function. To find the axis of symmetry, remember axis of symmetry is the x value. The minimum is going to be the y value. So I'm going to go back and look at that point. I'm looking for the gray dot at the top. So there's a gray dot right there. I'm going to click on it. And it looks like negative 1.818 for the x value. And for the y value, as I continue to open up new screens, there we go, negative 0.912. Okay. And let me just show you what happens when I try and graph the minimum and the axis of symmetry. So what I'm going to do is I'm going to go back over to this Desmos, and I'm going to type in my next line down. I'm going to type in x equals, and then that axis of symmetry. So that axis of symmetry was negative 1.818. So I'm going to type in negative 1.818. See how it splits the parabola? That red line splits the parabola. If I do the same thing for the minimum, or for the maximum in this case, it was negative 0. I can look. 912. See how it kind of rests on top of the parabola? It's almost like a seesaw. So let me make it a different color. Let me make it orange so that it stands out. There we go. Okay, so it's kind of like a seesaw sitting perfectly still on top of the parabola. That's how you get your maximum or your minimum. Okay, so the axis of symmetry splits it down the middle, and then the maximum or minimum, that just sits on top of it. Okay. All right, so let me get rid of those. And I'm going to go ahead to the next example. Close out that window. And for this next example, we're going to do this exact same thing, just more practice. So I'm going to start with the point 0, 0 this time. Let me close that out. And I'm going to clear out my table. So to clear out my table, I'm just clicking on each cell and deleting and deleting. Delete, 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 delete. Okay, so the first point was 0, 0. That one I remember. The next one, let's see, we'll do x's. So x is 1.7, 3.2, 0.7, 3.2, 4.3, and then 5.2. And then the y values, 5.1, 6.3, 5.9, 4.1. Oh, so this one is like a big guy. So the parabola is already there. And the reason the parabola is already there is because we left our formula in this next box. So it's looking up and it's saying find x1, y1 and create a parabola. So you can see with this one, it's definitely not perfect. Like this little purple dot up here at the top is a little off the parabola. And this little purple dot next to it is a little to the right of the parabola, but it's pretty good. And we know it's pretty good because that r squared value is 0.998. So we have our A, B, and C values. So we're going to go ahead and plug those in. So I'm going back to the notes, and we're going to say y equals, and then we've got negative 0.611. Oops, let me put a 0 in there, make it look formal. Negative 0.611. That first number gets an x squared. The next number is 3.967. So we'll say plus 3.967. That number gets an x because it comes second. It's the b value. And then for the c value, we've got 0.024. So we're going to say plus 0.024. Okay. So that's the equation of that parabola that we just graphed. Now what we're going to do is find the axis of symmetry. So I'm going to click on this box that has the, whoops, there went our parabola. And I'm going to go over here and I'm clicking on the line. I'm clicking on the curve. And I want to click on the gray dot. Don't click on that purple dot that's not quite on there. Click on the gray dot. And we get 3.246 as our x value. So that's our axis of symmetry. X equals 3.246. And then our minimum is the y value. And that looks like 6.463. If Desmos gives you 3 values, which most of the time it will, write all 3 values. Okay, so try to stick to 3 decimal places because 1 is just a little bit too short. Desmos worked really hard to get all those numbers. So give it all of the numbers that it does give you. Okay. And that is it for regression.